Hello, PreCal. So far, it does not look like a whole lot of you are watching these videos, so I'm not sure if I'm going to continue making them if they're not being used. So please let me know. If you just prefer, I can attach the videos that go along with the website, or I can, or if you're just using your books to figure this out, then that's fine. Just let me know. Okay. So we're going to be looking at lesson 5.4, and this is all about the sum and difference formulas. We're learning some more trig identities and formulas. There's just so many connections between all of these angles on the unit circle, and that's where all these identities and formulas are coming from. You can actually figure all this out using your unit circle. But sometimes it's nice to have these identities memorized or to just use them in a formula. So here, we're going to be using these formulas here. All of these say that if you have the sine of one angle plus another, it's equal to the sine of the first times the cosine of the second, plus the cosine of the first times the sine of the second. And you can see all these different formulas down here. This is on page 374 in your book. I'll write that on the notes here in a second. Tangent gets a little more tricky than these up here. But we can use this to figure out the sine or cosine or tangent of an angle of something that's possibly not on the unit circle, but could be made up of some of the angles on the unit circle. So we're going to try example 1 here together. This will help you with the first section of your homework. So let's get started. All right, so let's say I told you to find the exact value of sine of pi over 12. All of your homework problems are going to be working with twelfths. I don't know if there's other numbers that you can actually use for this, but all the homework problems seem to only be dealing with twelfths. Well, we don't have any twelfths on our unit circle, right? We only have a sixth, fourth, thirds, halves, but 12 can be divided by all of those numbers. So usually a 12th can be made up of some combination of those other angles. So this is 1/12. So 1/12 could be written as, 4/12 minus 3/12, right? So I could write 1/12 as 4/12 minus 3/12 because 4 minus 3 is 1. But 4/12 we know can be simplified into pi over 3, because if we divide the top and the bottom by 4, we get 1 over 3. 3/12 can be simplified to 1/4. So we're trying to make this angle into some form of what we can actually use on our unit circle. These are both on our unit circle, so we can use those. So now we know that the sine of pi over 12 is the same as the sine of pi over 3 minus pi over 4. So we can transform this into this. Now, in your homework, the first couple, I give you this breakdown. I give you what your angle can be broken up into. And then I ask you to do one where you have to figure out what the combination of angles is. Okay, so now we have the sine of one angle minus another. And if you remember, on our chart, we do have a formula for that. I hope you can see this. I hope it's big enough. So this second one here is the sine of one angle minus another. So that's going to be sine u cosine v minus cosine u sine v. And what I like to do when I'm using that is to I usually put a little u and a v above there. If whatever formula I'm looking at, if they're using u's and v's or other letters, that way I don't get confused. So this is going to be equal to the sine of u times the cosine of v minus the cosine of u again, pi over 3, times the sine of v. Now we can just break this down into the pieces that we know of the unit circle. So the sine of pi over 3 is, I'm checking my chart because I just want to do it the easy way. Sine is y, so the sine of pi over 3 is the square root of 3 over 2 times the cosine of pi over 4. I do have that one memorized. All the fourths are some form of square root of 2 over 2, right? Minus the cosine of pi over 3. Well, if the sine was this one, then the cosine has to be the other one, 1/2, right? Times the sine of pi over 4. Now we always multiply before we subtract. So I'm going to rewrite those up here. Square root of 3 over 2 sorry, I'm shaking the table. Okay, square root of 3 times the square root of 2 becomes the square root of 6, and then that's over 4 minus the square root of 2 over 4. Those have a common denominator, so we can combine them into the square root of 6 minus the square root of 2 over 4. All right, I'm going to stop this video. I'm hoping maybe shorter videos might be easier. Use this video to help you with the first section of your homework. I will work a tangent example in another video. This should help you though with anything that's sine or cosine, okay?